All right, I am going to attempt to walk you through how to make a PCB that you can mill on your home desktop CNC and how I do it. And so I'm going to start here in an empty schematic in KiCad, and hopefully we'll end up not too long with a file that you could then take to your PCB or to your CNC. And the file I've chosen is this famous circuit, the LPB-1. Simple. Um, so let's just dive right into that. So in the schematic editor, I'm going to hit the A key to bring up the things might be a little slow because I'm recording. To bring up the symbol placement window, and I'm going to type capacitor. So I'm not going to walk through how to put like libraries and stuff on. You got to have some libraries. I've got my own libraries too, and I'm not going to talk too much about that. But you can get libraries online with everything that you need. So if you type here the component you're looking for, these are the ones that I used, the PCM-SL devices. I don't remember where this stuff came from, sorry. And we're doing the non-polarized. I'm going to use a different footprint. I'm not using the ones they have. They don't have the one that I like. But I'm just going to place it here. So the first thing I do is place. So we have two caps. So before I copy and paste anything, I make sure this is set properly so that I don't have to go back and set a whole bunch of stuff later. So like I said, I'm going to change the footprint. So I'm going to click right here on this little stack of books looking icon. And here I have my own footprints that I've set up. So I like this one here. Oh, not that one. That's a special cap that I made for a special purpose, which is on this one. This is the one I like. And that's everything we're going to do in here. So now I'm going to select it, Control C, Control V, and then place it over here. Next, we need 1, 2, 3, 4 resistors. Same process. Add the resistors. Resistor. This is really slow because I'm resistor. Resistor. I think I have my own here. Oh, that's in the footprint. So I can, whichever symbol you like will do. So we have 4 of these, which I'm just going to, come on now. So I'm just double clicking on this, the symbol to bring up this window. So again, and now my components I've just selected, these have slightly smaller annular rings and just a little less copper than I like to have when I'm milling. And so I have my own, and you'll see when I bring my footprint up that I've made for a resistor. It just has a little bit bigger pad. So I will copy and paste 1, 2, 3, 4 of those. And then we're going to add the transistor. Now, I'm not going to type transistor. I don't have a 2N5088, but I do have a 2N3904, which is basically the same thing. And so we will add the transistor. And then I will just double click on the label and we will just call it 5088. And the last thing we need is a potentiometer. Well, not the last thing. Potentiometer. Potentiometer. So we'll stick that here. You can push while it's highlighted R to rotate it. You can push X to flip it back and forth this way. You can push Y to flip it back and forth this way. Then you can do the same thing with anything. So like if I, oops, now I've clicked with the. So if you select, sorry, just the text here, I can rotate just the text. I can flip just the text. So moving on. Oh, we do need one other symbol here. We need a ground connection. So GND. And that should be enough to get us started. Oh wait, no, I need my, I've made a few of my own symbols for connectors. So HSP is for Herald Street Pedals, right? I didn't put them as that. CNC, there it is. Put it as CNC. So we're going to add a ground pad. We're going to add an input pad. And I can click on it. An input pad. Put that up here by the input. I'm kind of placing these two roughly where they're going to go in the schematic just to make my life a little easier later. This guy can go, oh, that's okay. So what do I need? An output? Can I give me my window? Output pad, output pad. Oh, this is kind of painful. I might have to speed some of these sections up. Output pad. And what do I need? 9 volts. What am I doing? Add. Power pad. So now we've got all of that stuff. I am going to add one more capacitor because this schematic doesn't have any power filtering. So we will add a capacitor for power filtering. And we will add a reverse polarity protection diode. And I generally use a Schottky diode, the 1N5817. 1N5817. And we can just put that, oh, just stick it right there, connected already to the 9 volts. All right, so that's everything we need. That's everything we need, so I don't need this window. There we go. All right, so now let's quickly put this together. Probably fast forward this part so you don't have to watch the whole thing. So let's flip this guy. Let's flip this guy. They're going to be connected. Drag that out a bit. A copy of ground over to here. Pull it down. So we're going to have our capacitor. It's going to go here. I might copy one of these. We'll add one more resistor. So now we will go through and put our values in. So 434, so we've got a 390 here. We've got, what was that, 43K? We've got 430K. It was a 10K. 10K. This is going to be 100 in. This is what 100 in, right? Yeah. Really 100K. We're going to use A. 100K. This is going to be a 1M. This is going to be a 47U. And that looks like we're done. All right, save that. So we've created our schematic. And now I'm going to click this little green button. Well, first we have to annotate. So the first thing we do here, we have to annotate our schematic, which just gives it all the names. So we click annotate. I'm doing the entire schematic. We don't have any existing annotations. I don't generally mess with any of this because I'm not doing anything complicated so much that needs to be renumbered in any complicated way. I'm happy with the X position sorting. So we click annotate, and it's been done twice now. So now you'll see we have all these fancy things here. Okay, name C1, C2, etc. So now when we go here, I can click my update PCB from schematic button. Oh, I didn't put my, hang on. I didn't put my footprint in here because I don't know how, and if anyone knows how to do this, please tell me in the comments. I haven't searched out how to do it because it's not that big of a deal to do it for these 4 symbols. But how do I link this wire pad symbol that I've made to be the default symbol for something? That's what I don't know how to do. Okay. But then I just generally do this and copy this here. And then I go like this. And I just go paste. 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 And that's done. So we'll save that again. So that you have to save it or it won't update when you switch to the PCB editor. Doesn't matter. Don't worry. I have these all unselected right now. Generally, I think it's defaults to having these three selected, but it always screws up my schematic because I don't do everything according to the rules and the way the software's intended to be used. I tend to abuse it, like putting resistors over top of other resistors. All right, so there's all our components. Now, little plug. I have this handy plugin that I got off of GitHub, and it's the schematic. So what this will do will automatically place your components as they are in the schematic. So it kind of helps with your layout. Alternatively, if you don't have that, the way I normally would do it is I come in here and I select it by little sections. So like I'll select the power supply section like this, and then I'll Alt tab over here and you'll see it's selected those components involved in that, and you can drag them to where you want them. So this is like the manual way that I used to do it. So let's do it that way. And then I select anything connected to the power rail and I tab over and I drag those away. And then I select this input section right here. That's fine, whatever. So it's not so bad with the small schematic. We can imagine if you've got, 1 or 200 components on a board and you're trying to place them all, it gets a little daunting. So you just got to break it down into little chunks. And that's what we're doing right here. So then I'm going to just take these two guys and pull them out and down. Wow. And then that leaves this last stuff up here. So that's not the footprint I'm going to use. So we're going to change that footprint. So I'm going to change the selected footprint. Another one I often use is change all the footprints with that ID, that library ID, if you want to change like all 4 pots at once. That'll work, but we're just going to do this one for now. And the new footprint library ID will be my own personal one that I use. So I guess that could be another video, is how to do your own footprint. So I have my own off-board potentiometer, which is just those. Then I also have this one that I've made. So that's the one I like to use. I've got my drawings on there, but I don't want to look at those, so we'll turn them off. So you can use all these different layers to add different things. I remember I used to delete them because you can go into your whatever. You can go in your settings and you slim this list down to the bare minimum that's required. And that's what I used to do because I don't know what. But then I started using them all as I did more complex things and started putting things in closures, and I needed to have exact measurements. So I started actually going, I need more user layers than just 4, and I wished I could change the colors to better colors. Anyways, so now let's start building this thing. So let's drag our final thing down here. So the next thing you got to do is define your board. And so we are going to click Edge Cuts layer, because we want to draw on the Edge Cuts layer, and then I click Draw a Rectangle, and I'm just going to draw a rectangle. I'm not worried about what size it is right now, because I should have done this before, but you should have your sizes Right, so we'll just go 1590 BB dimensions, which should be in my, or not B, BB. We're going to be standard stomp box size pedal. Is it going to tell me? No. All right. 113 by 60. Right, so if our, so here's what you could do. This is sometimes what I'll do. If I wanted to, if I don't know how big to make the board, I will make a box on one of these eco layers. And I'll make it the size of the pedal box, like the pedal enclosure, which was what, 113 by 60, I think? Why can't it stay there? 113 by 60. So you can do that here in the properties. If you don't see this, you go to the view, panels, properties. So view, panels. This is, I use the appearance in the properties panel a lot. So I'm going to go to the width and make it 60. And I'm going to go to the height and make it 113. So that's the size of a pedal. So we can make our pedal board. We're going to have our pot. We're going to have our pot be right here in the middle. So what you can do here to line this up is you can click this and this, right click, align to horizontal center. So those are centered now. And then I'm going to grab this guy. And we'll have our jacks at the top. So that should be lots of room for everything. We'll have our foot switch at the bottom. And that's probably a good size for our circuit board. And so let's take this and this. And I actually do all three of them. And this. We'll align those all so everything's lined up. Now those aren't going to move. So I'm going to take this and drag it out here for a sec. I'm going to take this pedal, place it on here. I'm going to right click and I'm going to lock this part in place. So now that won't move. That's our base that we're starting with. You can turn off the eco layer if you don't want to see the box. And now we can bring in our pedals. So now let's bring our box back for a sec. So let's think about our pedal for a second. We have an input jack here on the left because this is upside down. We're looking at the bottom of the pedal right now. So our input is on the left, our output is on the right. Our power is going to come in at the top. So this is all going to be things you want to think about when you're putting it. So, or maybe we're going to have our power on the side, wherever that would change where I might want it. You also want to keep your power away from your signal stuff. So you want to just be thinking about these things. So we're going to have our jacks on top, and maybe we'll do our power on the side, on the bottom here. That's what we'll do for this pedal. So let's get a little square, and this will represent our foot switch. So a foot switch is about 20 by 15, I think. That should be it. Oops. Width 15, 20, something like that. We're gonna take another one of these, but make it really small. I don't care how small potentially, but just gonna represent our DC jack. So now you can see that everything fits in here, and we'll even add we'll add a little, whatchamacallit, LED circle. So that's going to have a 2.5 radius, roughly. Perfect. Yeah, LE on the top. Let's put it on the side. Put it over here for now. So now, let's get rid of that stuff so we don't see it. Let's select this stuff. Here's what we'll do. So since we know we have our power coming in on the left here, we're going to put our power connectors here. So we're going to take this stuff and just move it to this corner of the board. Alright, so let's break this down. We're going to put our power connector on the right and our ground connector on the left, because then I can add this diode, which is anything you're picking, it will highlight it on the schematics. If you don't know what a component is, click on it, highlight it, flip over, it'll show you where it is in the schematic. So Alt-Tab is something I use a lot when I'm doing this. Rotate this by pressing R. I'm going to put it like this. So these lines are your rat's nest. So those are the connections where everything needs to be connected. So you'll see if I go to the schematic, the 9-volt input pad is connected to the Schottky diode, which is then connected to the capacitor and these two resistors. So that's what you see here. So it's the pad connected to the diode, connected to this, which is also connected to two other resistors here. And now I'm going to have this rat's nest coming back this way so that I can work the trace like this and then into the board. I'm going to take my filter cap. Actually, you know what? I'm going to leave a little space because we're going to have, I'm going to use a ground pour. It's the best way to do this. So I want to make sure I have space for my ground to have lots of unimpeded path to it. I'm also going to rotate this capacitor. Right? Oh, too much. This, and we'll just pop that in right here. Power section complete. I'm not going to draw any traces yet because we're just placing stuff. This might change. Next, you can also line these up if you're really OCD. You can control click. You can align them like this. I'm probably going to move stuff again though, so it looks like I did a pretty good job of lining them up. All right, so next we have these two. Let's get rid of our eco layer again. I'm going to rotate those. We'll keep all our power on the bottom of the board here because we only have these two power connections. And that way, we won't have any power traces running anywhere near our signal circuit. We'll keep all the power distributed right along the bottom of the board here. Oops. Oh, come on. So I'm just going to stick those there for now. So then, like I said, we have all our, I should name these properly so you can see them. That's GND. That's plus 9V. That would be the output. OUT. And then over here we have the, oops, I can do it that way too. Over here we have the, oh, that's for the pad. INP. So let's take our input and let's put it on this side of the board. It can hold shift. So if things are snapping to the grid, you don't like, just hold shift and it will give you control over where you put it. Let's take our output jack and stick it here. Okay, so now we'll take our now we can start to line things up. So I'm just going to kind of follow these lines. We know where things go. So this is our input cap. Okay, let's just pull this up here. So this is our input cap. And this is our pull down resistor. So let's rotate that like so. We'll move our, we can just put it right there. We can put this right here. We can go down here and pull our other stuff in. So now here's where we're gonna just, looks like that's a good orientation. So we'll stick that there. This needs to be rotated. There we go. This can go right here. That's ground actually too. Let's rotate it this way. We'll put it right across here. And then we've got our, oops, other resistor right here. Sure, why not? Or we can rotate it maybe this way. And that's all our components. So now we can route things. Well, now I'm going to put the ground plane. So now we want to go to our copper layer, which now when we're milling for PCB, we want to do this on the back layer. Everything should be reversed because we are looking down at the board right now. So I click the copper layer, I click the draw filled zones, I click on the corner here, I click ground. Now my settings are clearance is 0.4, as is the minimum width. My thermal gap relief is 0.3, and the spoke width is 1.1. That's just how I like it. So now that we've done that, we're going to drag our square around, clicking on all the corners. They snap in, so that makes it easy. Once that's selected, you'll see these little blue hash marks around everywhere. If you press B, it's going to fill it all in with copper. If you push Control B, it will remove it. So that's how you do the pour. So now the next thing I do is I start routing. So we're going to go to nets and we're going to turn off the ground net. We're going to use a ground pour. We don't want to see those extra lines. So you see they disappear. And we just start putting things together. So our net class, I'm going to edit the predefined sizes. I'm going to give myself a 1mm trace, which is what I use for power. And I give myself a 0.8mm trace, which is what I use for everything else pretty much. Okay, so now if I click here, we're going to route our power. So go over the pad, press X. It's going to highlight the pad that it can be connected to. We're going to do that. And then this is all power, so I'll keep, and once you've hit X once, you're kind of in this mode. You can just keep clicking things. So that's done. We're going to switch to our 0.8 because that's all the power being distributed. We're going to go under this resistor. So it kind of wants to jump everywhere. So you're going to do this in steps. You're going to get it to go kind of the way you want and click. And then keep going and click. Keep going and click. Okay. And then we're going to do the same here. And that goes here. This is going to go under here. This is going to go here. This is going to go... This is going to go here. And this is going to go here. And I'm going to just pull that up just a bit. Oops. And this is going to go here and here. And that looks like everything. Oh, one more. And that's everything. Save that. Hit B. That's your board right now. You're done. Except let's Control B out, away from that. You've got to have some text on there. So we're going to do this. We're going to make sure reverse is selected, knockout is selected. We're going to give ourselves a 3x3 text, and we're going to put cool. And then we're going to make that actually go on a 45-degree angle. And now when we press B, if I go to these objects and turn up my zone, you can see. And if I push Alt 3, see how long this, you can see your board. Cool. All right. So, let's just quickly, I didn't mention, so in this thermal relief, the spoke width 1.1 and 0.3, that was referring to these, where there's ground connections. It's the size of these holes that it draws. And then that's just to help you soldering, because if you have a huge thing of copper and you're trying to solder to it, the solder's just going to go everywhere, and you're going to have heat, and it's going to be hard. And this helps keep the heat right around the pin when you put it through. So I don't always use them, but I do use them often. Sometimes if, say I have a ground pin in between two tracks or something, and there's only a sliver of copper there anyways, what I'll do is I'll double click on the pad, and you can go to your connections. In this connection to copper zones, you can choose to have a solid fill, and that way when you refill your zones, it'll just be a solid fill. If you want to undo that, you got to hit Control-Z twice, because undo that fill and then undo the actual changing of the pad. That's pretty much that. So now that we've got this far, we need to export the relevant information to our CAM software so we can do all the toolpaths. So that's done by clicking this plot button. Now it's going to have a bunch of stuff selected. We don't need any of it. We can uncheck the front copper. We're not going to use it. We have no paste. We have no silk screen. We have no mask. We have edge cuts. That's it. Edge cuts, copper, back copper layer. I use the drill. Oh, we got to do that. Before we do this, we have to tell the software where our drill and grid origins are. So you're going to go into the place menu. You're going to go to drill. You're going to, I zoom in to make sure I'm on the right corner. You're going to pick the corner of your edge cut here and click. It'll put a little red target on there. You do the same thing with the grid origin. That's what I do. I just originate everything from that one point. Now I'm going to save, and now we're going to plot. So we're going to unselect all this. You only have to do this the first time. Once you plot it, it'll remember what you plotted in your settings. So we're going to hit plot. You might get a message saying you need to refill your zones. Just click OK. Do it. Generate drill files. So once again, I think these are all pretty stock settings. The only thing I'm concerned with is this Exelon section anyways. We're using the the drill place file. Millimeters is my unit. Whatever this does, I'm suppressing it. And I've opted, so that is one thing I've done. I've opted for the plated through holes and the non-plated through holes to be in a single file, because I don't differentiate on my mill between plated through hole and non-plated through hole. I don't care. I just have holes. And that is already, so we're going to generate that. It's going to put all that stuff. If you want to change the output directory that it goes to, you do that here. Right? So, but it's otherwise it's going to put it into whatever folder KiCad is using for this project file, your project folder. So once that is done, you can close that. We are done in KiCad. I'm going to open FlatCAM. This is all free software. Now, FlatCAM, we may get frustrated with, because I'm using the beta version because it's better. Except that it crashes fairly consistently. And then, so we will have to see how this section goes. I may have to fast forward through all this too. I should have opened this software before I attempted this. Oh, wrong one. It just does not want to open. Anyway, so I'll show you where those went. To my demo folder, KiCad demo folder, which I think I put in here. In here. Demo test. KiCad demo. So there. So now what that did was made these 3 FlatCAM files. Demo edge cuts, KiCad demo back copper, and KiCad demo drill file. Once we open FlatCAM, so you're going to get the 8.994 beta version of FlatCAM, and you're going to just be frustrated unless you want to pay for CopperCAM, which I may end up doing because it's superior to this software. It doesn't crash. From what I used in the demo, it can make a little small PCB, but it costs like 200 euros or 180 euros or something like that. So I just haven't bit the bullet for it yet because I've just frustrated myself with this. So we are going to open a Gerber. We're going to go up to we're going to go to where we keep the file, KiCad demo. We are going to, so you can just select both of these Gerbers. So that's what GBR is, the Gerber file. That's the file that KiCad outputs that your CAM software, your CNC software can understand. So we're going to open both of those. Now remember, we did this backwards. So I've done it on the front too. It'd probably save a little time if I just did it on the front properly but I messed things up. So this is the method that I have. This is just the procedure I've done. So this is what I'm used to doing it this way. Excuse me. Oh, where are we here? Brent copper. Oh, we need the drill files. So we're going to open the drill file. So there it is, but it's backwards. We don't want to mill it backwards. We want to mill it frontwards. So we're going to double click on all these. Transformations. Flip on X. Edge cuts is a square, so that was dumb. We don't need to flip a square. But this we will flip. And our holes we will flip. Transformations. Flip on X. And nothing will line up. Watch. Why? Because I think because the hole, like the square that's drawn around it is not to the edge. That's another thing. If anyone knows how to make this automatically always line up without me having to offset it, that would be awesome. But if you do this, you can just offset these holes. Let's go to like 0.05. Oops, 0.05. So I just kind of get them in the right spot. When you're using this, do not neglect to click save after literally everything that you do. Save it in the right place. Content, KiCad demo, and we're going to name it a better name, KiCad demo. Next, so now we have all this in here. We go to our drill file. These are all different size holes, and I'm just going to use one drill bit to drill this. I'll probably just use a 1mm bit. So I'm going to go into my Exelon editor, and I'm going to switch everything that's not 1mm to 1mm, so all our holes are the same size. I could have done this in KiCad because I also have this little plugin, the set hole diameter, which I could have done that, and now they're all 1mm. But we did it here too. So exit, click yes, I want to save. It's going to give you two drill files after this, the edit and the regular. I'm going to right click on the regular one and just disable it. So we only are showing our edited plot. Then we're going to double click on there. We're going to go to drilling tool. Now this is where you're going to set your settings. Cut Z, that's the thickness of your copper, and I suggest going 0.1 millimeters thicker. So my copper is 1.5 millimeters thick. I'm going to go, oh, it's a negative number. It has to be a negative number. And for some reason, oh look, we're gonna crash. Luckily, I have two more instances of it open. Look at that. So let's open under development. Open. You can see why I'm considering paying for software. All right. Quickly getting through this. My ADD is starting to take hold. Where are we now? We did our edge cuts. We can do edge cuts. So, we were doing drill. So, drilling tool. So, thickness was the thickness of your copper minus 1.5. It's a negative number because we're drilling down. I'm putting 1.6 because I go 0.1 thicker. Sometimes I have 1.3 or 1.2 millimeter copper. I use 1.3. Travel Z, that's how high up above the copper it goes before it moves to the next hole. You could use 0.5 millimeter because it's a flat PCB. I use 2 millimeters because I don't want any problems of things getting caught. Feed rate for drilling, I like to use 150. Those are, I think, millimeters per minute. Is that what it is? In millimeters per minute? Millimeters per minute, right? Anyways, that's the plunge rate that it goes down. Everything else, like the dwell, spindle speed, I use 16,000 RPM. And now, I use a Viver desktop CNC, but it's a GRBL. But I just use the default no M6 preprocessor, and it works for me. I've never tried anything else. It does everything I need to do. I like to make my N move 0 and my move Z. This will be different potentially for your machine, so you may have to try different settings here. I don't know exactly what to tell you because I only have one machine and I've only ever used one machine. This is what works for my machine, so maybe start here. Obviously measure your spindle height and stuff. If it's only a 30 millimeter spindle height, don't try to set it to 45 millimeters. Anyways, and then you're going to generate the CNC job. and that is going to give you your holes. Save. Click Save. Okay, so now we've got all of our holes mapped out to be drilled. Toolpaths. We're going to do the same thing for our edge cuts. This time we're going to use the cutout tool. I'm using a 1.5 millimeter end mill to cut my boards out. I should probably get a smaller one because 1.5 millimeters is a lot of copper to cut out just to cut your board out, but that's what I'm using right now. Once again, we're going minus 1.6 to make it all the way through our copper. Now I'm using a multi-depth because you do not want to try to do this in one pass. So I was using 0.25 and now I'm even gone down to 0.2 because it's really noisy when you try to do too much. I keep no margin. Now gaps, this is what you need gaps to hold this in place. Otherwise, once it starts to come out, it's just going to go flying across the room, or it's going to get stuck, or it's going to just, your whole life is going to be messed up for like 20 minutes. These are like the little tabs that hold it in place. So the settings I like to use there that's this gap size, 0.5 millimeters. So it just leaves like a 0.5 millimeter gap, which is just enough to hold it. And I'm just doing them on we'll do the top of them. So you have settings. You can have none, left and right, top and bottom, one on every side, 2 on the left, 2 on the right, 2 on the top, 2 on the bottom, or 8. Now that's a lot for me. I'm going to do top and bottom on this one. And then we are going to generate the square geometry because this is a square board. It has no crazy stuff going on. So there's our geometry. Save. Right, now let's go to our geometry and we are going to do the toolpath, or do the actual CNC part here. Tell it what we're doing. So we're going to go 1.6, multi-depth -2, travel Z is 2, feed rate, I'm going even down to 200 now. Ooh, not 2,000, 200 now. Otherwise it's really noisy and doesn't make a nice edge. Once again here, 0, 0, 45, default no M6. We're going to generate that CNC job. That's done. Save. So you see the blue line means that the CNC job has been created from the toolpath. So that's the G code has been created. Now we got to do the copper. So this is the one that takes a little longer sometimes, especially if it's a big board. You can be sitting here waiting for it to plot for like 10, 15 minutes. I've had for some really complicated boards I've done. Sometimes it crashes and you start all over again. So it is what it is. We work with what we can when we don't want to pay for it. NCC tool is what we're doing. We're doing a copper clear. Non-copper routing. Non-copper clearing. It's a funny word. It always bothered me, but that's what we're doing. So we're going to open the NCC tool. Here's the funky thing. Sometimes it doesn't work. And I found a little workaround, so I suggest just doing this because otherwise you might save yourself some frustration later wondering why the code's not plotting. Even though it says that it has plotted, but there's no code and there's no toolpaths plotted. So my workaround for that was I think it has something to do with the tool size. So I double click on here and I make this now 0.0001, oops, sorry, 0.0001 millimeter bigger. It's barely bigger at all. Don't worry about this. Is for if you have multiple tools, if you're going to add them from the database. We don't need to worry about that. We're doing a clear step over. So your overlap, I've just been using 50%. I tried a bunch of different ones. It doesn't seem to make a whole lot of difference in the end when you're making a PCB. So I've kept it at 50% now. I'm just using a combo method, no margin, connecting all my polygons or draw lines between. These have always been checked, so I've just always left them checked. And that's everything. So we're going to generate that geometry. Now this can take a minute. Always look down here because it tells you what it's doing. So that's going to fill all this in with red if we did it all correctly. It's going to think about it, and then it's going to draw all the paths through all these traces in red. This will be fast forwarded likely in the video, or maybe not. Maybe I'll force you to sit through it with me. You can click ahead, right? Yeah, you can totally click ahead. I'm going to make you guys do the work. I'm just going to post it like this. 69%. All right, now it's got a plot. So we got our toolpaths right here, our geometry, and there it is. Let's plot it. Cool. Save. Remember to save every time. You do not want to wait through a long one of those and then get working on something and it crashes and you didn't save. Trust me. So now we got to make the G-code. So now this is where we keep our tool the proper size. We don't put the 1 here. We keep it the proper size. Mine is a 20-degree V-bit. So you're going to put your own, whatever bit you're using, that's what you put here. So if you have a 0.2 30-degree bit, put that in. Don't use my numbers. Use your bit size. Same as before when we did the tool pathing. Everything else the same. 250 is good here. Again, I'm going to make this 45. Again, I'm going to make this 0, 0, because that's going to bring my bit back to the home position and up so that I can change it and not have to move anything. So if you adjust things, you can lose steps, and then it's not good. We're going to generate that CNC object. And we're going to wait for a minute. It might not take too long. Okay, so we did that pretty quickly. Is it going to give it to us? So this is where sometimes it'll plot and finish, but the G-code will be empty. You won't get it all blue like it just went. It'll stay red. The numbers won't appear. Save. And that was what that fix when I made the geometry. I made it a little bit bigger than the bit, and it seems to always work when I do that, and it seems to never have any negative results in my end product. So that's just what I do all the time now to save headaches. I saved, right? We're just going to click it again for good measure. All right, so this is all done. You're done. All you literally have to do now is right click here, click save on your copper. Make sure you're in the right folder where you want to be and save it. Do the same for the edge cut. Save. Save it. Save. Save it. Now when you open your CAM software, which is, I'm using OpenBuildsControl version 1.0.390. There's another board I was working on. So you can see